My computer's acting like it's out of RAM, but it can't be out of RAM. It has 16 gigabytes. It's working.
You made it around the way. You made it. But now we still have to kill it.
Alright.
This is a great one.
Overwatch is only a good way to understand something. I don't want to hear about your complaint.
I love the good and like actually you're like playing, but it only wants to be
yeah, like it like
you know, I would just say we have it. I don't as long as we actually have
like right away. The algorithm's not I'm super excited.
yeah, about I've made one before, yeah.
Theoretically,
It's my phone. I'm not sure the name.
because I didn't install.
Yeah, you're not getting any firefighters.
Yeah, that makes it in.
About Friday.
I would have probably figured that
As long as you don't give not now strictly to that attribute, then it is optional, right?
Yeah, as long as it's knowable, it can be optional. I would recommend in your design, you know, trying to avoid situations like that, especially in the databases class. So, like, you can always avoid, sometimes it, you know, a lot of times you can avoid having though by having like user star table with like object ID and table. So lack of presence in that table implies so like instead of having if you're sure to hit it instead of having something like I don't know, like ID whatever this mobile thing is, which you can have
Yeah, there's
is
It's N plus
D,
and then
other, like knowable.
So did you change much of your database back to
It used to be a weekend Z. Something like this sort of thing. So that way, yeah.
This is the week ending.
Yeah, so it would be like, I was using a recommended, but for cases like this,
Bad thing about this.
it's not that bad, but just in general in your database, if you have, that's like extra, or it could be, let's say in your database it was like, you know, is admin, or something like that. If you just have a Boolean variable like this, you have a Boolean variable like, you know, false for everyone, like there's lots of that, versus if you only have one and you just put it off in this other table.
Oh, in that case, yeah, that's.
And it's the same thing with like nullable. That's the idea.
Did you mention that?
Yeah,
This is not always desirable, but
Right.
it can be a way of
It
avoiding
makes
it.
sense in this case.
Well, we're probably asking you to see.
Yeah.
What he said.
So
Today we're going to continue the discussion on SQL, and hopefully I will be able to finish most, if not all, the discussion on SQL. Then Monday, I believe, unfortunately, is another holiday. Is that right?
Yes.
All right. So it's very unfortunate that it collides with our class yet again. So we have to lose one more lecture because of that. But nonetheless, the project phase 1 is still due on Monday. Just a reminder for you. And the due date is Monday, and the due time, I forgot what time I specified in the project specification.
11:59 p.m.
11:59 p.m. Okay, sure. So you have the entire Monday to still work on it. And we will do electronic submission, and the Canvas submission set will be shut off immediately at that time. So make sure if you think your submission is ready, you should go ahead and submit that early rather than wait till the last minute. I think I will take a few minutes to answer any questions you have regarding the project. Any questions regarding project phase 1, the design phase? Any question you have?
So,
Yes, go ahead.
oh, sorry.
Go ahead. I think you're
In one reservation, you can one user can only reserve one specific temporary house for a specific time, right?
That's right. So one reservation concerns about only a single TH over a specific period of time. Yes. Actually, he's here first.
On the or on
Can you
the,
speak loud so people in the back can hear you as well?
on the visited and the reserved tables,
On the visited and reserved table, okay.
yeah, then the dates, should those be connected in any way, or are they irrelevant to each other?
Okay. So let me repeat the question so folks in the back can hear what he was asking. So specifically, he was talking about the visits and reserved tables. Okay. By saying tables, I assume in your ER design, you have a visits and reserve relationship set. And somehow they're turning into tables based on your design. Okay? And the question was, so both visits and reserve have dates, right? You visit a particular TH over a specific period of time, so does a particular reservation, right? So the question is, do those dates have any relationship whatsoever? Without what you're asking? From a business logic point of view, yes, a visit can only happen over a period of time that the particular user has made a reservation over that period of time for the same temporary housing prior to your visit. Does that make sense? But if you look at the product specification for phase 1, we specifically mentioned that we do not expect you to enforce any constraints in your design phase. In other words, yes, there is this inherent business logic that should be enforced as a constraint, but we don't require you to enforce such constraints in phase 1. Do I answer your question? Okay, fantastic. Yes?
So you mentioned that users have sessions and that they should have their, essentially any activity they do stored in that session before it's added into the database?
Yes.
So should we like separate out sessions, like what uses their activity before we add it into our actual, like, you understand what I mean?
Could you please elaborate a little bit on what you mean by separate sessions?
Well, so you mean, because before...
For the same user or for different users?
Well, for multiple users, I guess.
For multiple different users?
Yeah, you would have different sessions, right?
Yes, that's right.
And so the only issue is you said that we should be able to store the information before we commit to the database. So should we have...
Oh, I see what you're saying. So what I mean by that, first of all, this doesn't concern you phase 1. This is actually an implementation issue
Oh, I see. Okay.
for phase 2 and phase 3. in particular, what I mean by that is you should allow your system to store those information temporarily within the session of your program and within the user session. And only when user is ready to commit, meaning it's kind of like a shopping cart concept, right? When you go to Amazon.com. Right? Dilly, you want to add something?
I wanted to comment on that. Just I think to clarify is that it doesn't actually need to be stored in your database at all until it's been committed. So you can just store it in like a cookie for web or just in your application state, whatever.
In your data structure of your
Yeah.
application, yes. So it's kind of just relate yourself to your shopping experience on Amazon.com or any of these e-business websites like Airbnb. You shop around, you add a few items to your bucket list. But those are bucket lists, right? They're not materialized until you check out. That's what I mean by that. Okay? Good question. Any other question you have before it's due on Monday? Yes, one more. Yeah, go ahead. Yeah, sure.
So, somebody reserved a place, but he might really go there or not go there.
Okay.
Is there any distinguish between these two cases?
No. So in our product specification, we do not enforce a user to go to a place he or she has reserved. So you can make a reservation, but you don't actually have to go.
Okay, then he can still, even if he didn't really stay over there during that time, he can still do the rate or
Feedback?
Yes.
That I have to go back and look at what I said in the specification. I believe what I said is you can provide feedback for a temporary housing you have actually visited. So you have to have a reservation record in order for you to make a feedback on that temporary housing. But again, this falls into the category of constraint checking, and we don't require you to enforce this in phase 1, in your design phase. Yes?
It seems like there's some arbitrary choices, like specifically one I was looking at is, can multiple people own one temporary housing, or does one temporary housing have to be owned by one person?
By owning, you mean owning in sense of reservation or in the sense of listing it as a property of yours?
Like leasing it as a property.
In real world, yes, property can be owned by multiple people. You can jointly own a property, but in our system, let's simplify that. Assume each temporary housing is owned by just one user. But owning, I mean owning the property for listing, not owning in the reservation sense.
Yeah.
Okay. Over there, yes.
So the user can have more than one property or no?
A user can have multiple property, but each property is owned by a single user. So it's one to many from user to the property. It's not a many to many. That's what I mean.
Okay.
Does that make sense?
Perfect.
Okay, perfect. Any further questions? Okay, if not, let me give you a quick roadmap, quick look ahead what to expect next. So I will be releasing homework 3 on SQL fairly soon, depending on the progress I will be making today. If I make fairly good progress today, I will be releasing that either later today or tomorrow, definitely before Friday. And then Monday, unfortunately, as I mentioned, it's a holiday, but phase 1 is due. And then on Wednesday, when we come back from the holiday, then I will be releasing project phase 2. I will spend 20 minutes also to go over the code structure for your phase 2, because in phase 2 you will be actually start coding your project, right? So good news is I will not ask you to code from scratch. Rather, I will provide a skeleton of the code base that I have developed, so that you will basically take that skeleton that I will be distributing out, then build your functionalities, build your system around that. Of course, you don't necessarily have to follow the same code structure that I will be providing to you, but I strongly recommend you use that at least as a reference point and go from there. Okay? So that will be what to expect next. So you will be having homework 3 and project phase 2 coming up. So that's kind of the roadmap. Okay? With that being said, let's continue with our discussion on this. Okay, so this is where we stopped, where we said the difference between exists, a market set A versus unique. Okay, right? So where in this case, this is true if and only if A is not an empty set. On this end, this is true if and only if A is a set. Because remember A is a market set. A set, by definition, is a market set. Consider it. So essentially meaning, i.e., if you don't fully understand the mathematical definition of set, what this means is A has no duplicates. Right? A has no duplicates. So coming back to this example here, what this query does is to find sailors who reserved both 1 and 3 only once. Another possible outcome of this query is that find the sailor who reserved both 1 and 3 at most once. Exactly once, at most once, there's a subtle difference there because you sailors who has never reserved both 1 and 3. That depends, that subtle difference depends on the underlying system, how they have implemented the following, which is unique over empty set. This is true, of course. As I mentioned in last lecture, the behavior of this is undetermined. It really depends on the particular system you're using. Like different vendors might have chosen to implement this logic differently. So depending on that, the output of this is to find sailors who have reserved 1 and 3 exactly once or at most once. Any questions so far? Okay, so that's what happened here. Now this is an example where the inner block, which is the second select from where construct here. That's what I call the inner block. This is an example where the inner block is correlated with the iterations you will be doing as the outer block. In other words, the content of the inner block will actually change when you go from one serial record to the next serial record in the outer block. This is to be contrasted with this example where the inner block is independent of the outer block. In other words, you can pretty much view the inner block as a loop environment and take it outside the outer block and evaluate once for all. So from an evaluation point of view, this obviously is much more efficient. Of course, assuming you have a good optimizer, good engine, right? Because a dumb engine can ignore this loop environment and still evaluate this every time for every single iteration of the outer block. But most engines are sophisticated enough or intelligent enough to figure out, oh, this actually is the environment. I can evaluate this once for all iterations of my loop. But you cannot do that. But even for a smart engine, you cannot do that for this query. Right? You cannot do that for this query, where the inner block is correlated with the outer block. So you cannot simply take the inner block and evaluate that outside the outer block once for all, because the content of it actually change from iteration to iteration. Okay? So that's a remark I like to make. Now, there are more set comparison operators. So we have talked about exists, unique. We have talked about in and not in. There was a few others which I will go over next. The other one is there are two of them that are quite useful, which I'm going to show you right here. The first one is you have a value. This is a value. followed by an operator. This is a logical operator, such as less than or equal to, greater than or equal to, or equal. Right? This is a logical operator, followed by any and a marked set A. Okay? So this is the one construct. And what this says is this is true if and only if there exists a value x from the marked set A such that the operator over x is true. Okay? So that's the logic of this. To give you an example, I want to find Sailor whose weighting is greater than the sum of Sailor, some Sailor called Horatio. Okay? So for example, you want to compete against the Horatio family. Right? Horatio family has a couple of Sailors, and you want to compete against them. But your goal is not to beat all of them, your goal is to just beat any one of the Horatio Sailors. So that's what you do. You say, okay, where my weighting is greater than any of this. So this is the marked set A here. In this particular case, the marked set A contains all the ratings for the Horatio Sailors. Does that make sense? And this evaluate to true, meaning this is my value V in that construction over there. This is the marked set A over there. My operator in this particular example is greater than. I'm using any. What that means is this whole thing is a Boolean expression. This whole thing is a Boolean expression. And this evaluate to true if and only if there is a rating value from this inner block that's less than the current Sailor's rating value. If that's the case, I return such a Sailor. So at the end of the day, what you find from this query is all the Sailors whose rating is better than at least one of the Horatio Sailors. Okay? So that's what this query does. Now there's a variation of this. If you understand this with no problem, you should be able to understand the next one very easily, which is I change this any operator to all. Okay? What that means is this means this is true if and only if for any x in A, this is true. So this is where human language has ambiguity, right? When I say I'm better than any Horatio Sailors, what do you really mean? Do you mean you're better than all of them, or you're better than any one of them? This is where human language has ambiguity in its syntax, right? But in database language, in the context of SQL, any means one of, okay? All means all of, right? So that's the difference. So, meaning if I change this to what do I get? What I get is I find the Sailors whose rating is better than all Horatio family Sailors, Sailor from the Horatio family. Okay, so that's what I get. Here is a summary of what I have been giving out on the whiteboard. So basically, they summarize all the set comparison operators that we have gone over. Okay. Now that being said, recall that I did this simple experiment with you using this keyword intersect, right? And I mentioned that we actually did this experiment in MySQL, and the experiment showed that this keyword intersect is actually not supported by the MySQL database server. So the question was, then we asked our question, how do you implement this operator in a database server when this operator is actually not supported? So one way of doing that is to use the keyword in. Okay, so let's go over this together. So suppose I want to find sailors who have reserved both a red and a green color boat. I want to find both such sailors. How do I do that? The way we used to be doing this is to use the intersect keyword. We find the top block, find the sailor IDs who have reserved red color boat. The lower block, find the sailor ID who reserve green color boat. Then we do an intersection of the two that must return the sailor IDs who have reserved both a green and red color boat. Okay? And when this keyword is not supported, we have different ways of doing this. This is one way of doing this. We use two joins simultaneously. This is one way of doing it. The other one is to use the renaming operator, right? And carry out the join between those with the red color boat and those with the green color boat. This is just a quick recap of what we have done before, right? Yet another way of doing this query is to use the keyword in. So the idea is as follows, okay? So the outer block, if you look at this outer block, it's very simple. It basically finds all the sailors who have reserved a red color boat. So that's what the outer block is doing. This part. Okay, I'm doing a join between boat and reserve. I'm enforcing the condition that color must be red. But at the same time, you must be a sailor who has reserved a green color boat. So how do I enforce that? So another condition in my where clause of the outer block is to claim that the sailor ID for all those who satisfy this join condition, only for those who satisfy this join condition, and in addition, not only you need to satisfy this particular join condition, meaning boat ID match and color is red, your sailor ID must be from the set of sailor IDs who have reserved a green color boat. Okay? This actually implements, if you think about it, this actually implements the intersect logic, right? This implements exactly that. And similarly, the keyword except, which is set difference, right? Which is set difference, A minus B. Okay? Can be implemented using not in. For example, if I replace the keyword in here with not in, what do I get? I got sailors who reserve a red color boat, but not a green color boat. That's essentially A minus B, where A is the set of sailors who reserve red color boat, B is the set of sailors who reserve green color boat. If I use not in here, I get exactly A minus B, which is the same effect as if you were using the keyword except. Okay? Now, let's turn our attention to division, right? So A divided by B. Okay? In particular, let's say I want to find sailor names who reserve our boats, who have reserved our boats. Let's pause for a while. Without looking at this yet. Let's pause for a while and let's try to recap how we do this in relational algebra, right? Which we had discussed already, right? But just quickly recap. How do you do this in relational algebra? How do you find sailor names who reserve all the boats? Okay? So you find all the boat ID from the boats table, right? Then you use reserve, divide by this, but remember, reserve has sailor ID, boat ID, and date. If you were just to do division like this, what you find is sailor ID who reserve all the boats on the same date. Right? Does that make sense? So you cannot just do this. You have to put that out, the sailor ID and boat ID, so that which day you have reserved a particular boat is relevant. Which date you have reserved a particular boat is relevant. Yes? Question?
So, am I mistaken though that I thought when you did division, the left argument was required to only have 2 columns and the right?
No. You can, of course, have multiple columns. The output is A divided by B. A doesn't have to be 2 attributes or whatever, or any number. A can have any number of attributes. The only thing is that the schema of B must be part of the schema of A in order for this to make sense. And the output schema is whatever attributes in A but not in B. It says nothing about, oh, B must have only 1 attribute and A must have only 2 attributes. No, that's not what we said. Okay. Yes.
So, and just to recap, then there must always be like at least 1 more attribute in A than B, or otherwise you're out.
Yeah, of course. Otherwise, this doesn't make sense. Yeah. There at least has to be 1 more attribute in A than B, but can be more than 1. So we put out our boat ID, and for example, it's perfectly okay to do this. So well, so that this cost will come back. Right? So that's the example of it. But of course, what we want to do here is different. Right? What we want to do is find sailors who have ever reserved all the boats, regardless which dates those reservations are made. So we have to put that out. Boat ID. Okay? And what's the output of this? Division is sailor ID. Okay? There's no need for you to do this at the end of the day, okay? This is totally unnecessary. This is not wrong, but you're just projecting yourself out, get the same thing back. So there's no point of doing another projection to find the sailor ID. This already returned you a list of sailor IDs. Then you take this whole thing, you natural join with sailors. Why? Because you need to find the sailor name. Then you put that out the sailor name. That's it. Okay? That's how we do this in relational algebra. How we do that being said, how do we do this in SQL? There are 2 different ways of doing division in SQL. We are not yet able to discuss the second approach because it requires another feature that we haven't introduced yet. But we are able to at least introduce the first approach. It's actually a very interesting approach. Okay, the way you do this is the following. Okay, what kind of sailors are we looking for? What type of sailor we are looking for? Okay, we are looking for sailors who reserve our boats. But that essentially is the same to say we are looking for sailors such that there's no boat he or she has not reserved. So it's a double negation logic, right? For example, if you go to a Super Bowl party, your friends might be literally chatting around and say, oh, he has watched all the Super Bowl games. Another person may say the same thing, say, oh, you know what, there's not an even single game he has not watched before. In that kind of environment, most times people actually say the latter than the former, right? Because the latter, the double negation gives you more kind of emphasis. Does that make sense? You know, when I go to a pub or something, I watch all the games. I would rather say, there's not even a game I never watched before. The latter sounds more, I don't know, it just feels like more standing out, right, if you ask me. So we are using exactly the same logic here. The same logic, right? Sailors reserve our boats is equivalent to say, there's no boat that this sailor has not reserved before. There's no game this person has not watched before. The same thing, right? The same logic. The only thing left is how do you express the latter, meaning a person, there's no game this person has not watched before, there's no boat this sailor has not reserved before. How do you express the latter using SQL? So let's go over this together. What you do is the following. First of all, you try to the outermost block. So we have, this is a two-level nesting in SQL. Two-level nesting in SQL. The outermost block iterates through the sailors table. So it goes through the sailor record one by one. For each sailor, you return the sailor name if this thing is not exist. From here to here. You can ignore all of this. So actually, I'm going to use the whiteboard to do this. So I'm going to. So these are my sailor records, suppose. Okay. So what I'm doing is I iterate through the sailor record one by one. So let's say I'm currently at the second sailor, and I will return this sailor, the sailor name, if and only if now this whole black box. You can view this as a black box at the moment. And what this black box does? Well, what this black box does is, you see, crystal ball, return me the boats that I have not reserved. Okay? The boat, sailor 2, has not reserved. Of course, this will change while you iterate through this, right? If you go through sailor 3, this will become sailor 3. This black box will change its condition. Now, this obviously works, right? Because if this is not exist, if this is an empty set, what that means? That means there's no boat you have not reserved. So you must have reserved all boats. Do you follow me? So far so good? So it boils down to how we construct this black box. Suppose now you begin with this black box, and you know how to construct this part. That's just select sailor name from sailors where it not exists. Right? That explains the first part, the outer block. So how do we construct this black box? So our task now reduced to, for a given sailor, find all the boats he or she has not reserved. Right? How do we do that? Well, the way to do that is I'm gonna continue from here. Is that okay? To do this, okay. Go through each boat. Okay, go through each boat. Return. Let me use BI to index the ice boat, which means the ice boat. Return BI if and only if not exists again. Now I'm going to use black box number 2. So another black box. What is the black box? So remember, your goal is to find the boats the current sailor has not reserved. That's equivalent to say I will go through each boat and I will return this boat record. If there is no reservation record showing the current sailor reserved the current boat, that must be a boat that you have not reserved.
So that second black box, for my discussion I just said, what is it? Is because you're using not exist here, so the second black box basically return all reservation record showing, let me use Sj here, and Bi, Sj, so that's like 2 for loop, Sj and Bi. That's it. So the second black box is to return all reservation records showing Sj and Bi. In sailor J has reserved both I. If this is empty, meaning not exist is true, not exist only become true if this becomes an empty set. What that means? That means there are no reservation records showing sailor J has reserved both I. Which means, again, back to the plug that into the first black box, that means sailor J has not reserved both I. And if this is true, for all the boats, if the first black box never return anything, if this, that's for boat I only, right? But if you do this for each boat, and if the first black box is never return anything, at the end of the day, that first not exist become true, because that become empty set. What that means? Well, the sailor has not reserved any boat. Then you should return that sailor. Sorry, there's no boat the sailor has not reserved, so you should return that sailor. There's no boat that sailor has not reserved. So, this first pair of brackets, opening and closing, from here to here, that gave me the first magic black box. The second pair of brackets here, that gave me the second black box, which is this. Return all reservation records showing the combination of Sj and Bi. That's exactly what happened here. From reserve, where boat ID must equal to the current boat ID, and sailor ID must equal to the current sailor ID. So that's, you can imagine this is Bi, this is Sj, while you are iterating through these loops. Any question on this? Looks complicated, but it's actually fairly straightforward once you understand the logic. So remember, in exam, if you do division, you don't know how to do, just think about in a bar, you say, there's not even a single game I have never watched before. That's exactly how you do division. In fact, if you write down that sentence, I give you 1 point. Doesn't have to be a game, something, there's not even a single class I have not taken before, something like of that nature, right? So I will give you a point. Mark my word. Of course, you can only get full credit if you translate that to SQL, which is this. Okay. This is essentially saying that in SQL. Right? It's the same content, but you're just speaking a different language, essentially. Okay. Of course, with the advance in machine learning and AI, artificial intelligence, maybe one day that's all you need. Maybe one day when you see that in a database exam, you get full marks because the machine is smart enough to translate that to SQL for you. All you need to say, oh, there's not even a single game I never watched before. 1 second later, this comes out. It's possible, right? Definitely possible. With the way AI is advancing, I think totally possible. Okay, all right, so that's that. Okay. Now, some summary I will skip. Now let's move on to some more advanced features of SQL. The first thing I want to do is aggregation. So some of you, actually at least 2 of you, one of you actually posted this question on Canvas when we were working on homework 2. The question was, oh, what about aggregation? Does relational algebra support aggregation? The answer is twofold. For the standard definition of relational algebra, no, they do not support aggregation. For the expanded definition of relational algebra, later on we will have discussion on that, it does support aggregation. It has to, because relational algebra is used by the database engine to represent an incoming SQL query. And SQL query definitely supports aggregations. So for that purposes, in order to represent as the translation of SQL to something machine can understand, relational algebra in the expanded sense has to be able to support aggregation. But in the standard form of relational algebra, they do not support aggregation. Now, back to SQL, what kind of aggregation operators it does support? The SQL does support. So it does the following. Start from the basic ones. I want to do the basic aggregations. We all know, right? Since kindergarten, counting is the most basic form of aggregation. You count how many candies you get, right? Then candy, at some point, candy is not good enough to satisfy you. You want to count how much money you have. Then you cannot just count, because $100 and $10 and $1 bill is different. But it's interesting to look at my daughter. When she is little, she just counts. You give her 3 $1 bill. She thinks that's more than a single $100 bill. Because, right, that makes sense? At that point, they only understand count. At some point, they realize, okay, $3 can buy 3 candy, $100 can buy a lot of candies. There's a difference, so they do sum. Right? So you have to be able to support count and sum. Right? Then we have a group of friends. Oh, you want to see how much money each one gets, then average. Right? So those are basic aggregations database system support. So as simple as count, average, and these are fairly easy to understand. Right? One small complication here is you might combine aggregation operator with the keyword distinct to get rid of duplicates in your count or in your aggregation. So I will demonstrate this using a real query against our database. Let's see if I get network connection here. So obviously I do not have network connection. Okay. So let me so the server is down for some reason, so okay, so let me see whether I can use another database to show this. Okay, something's wrong today. Try again. Okay. So here is just a very simple database. It's a TPCH database, right? So it has customer, nation, and things like that. So let me see, I want to select from nation, so nation. So there's you look at the schema of this, you have a nation key, that's a parent key, nation name. the different nations, and nation region key. That means which continent you're from. Which continent you're from. Okay? So I want to do the following, which I will do select count from nation, right? So what does this do? This will return me how many nations I have, right? So 25 nations. Now if I do select count, what's the name of the other attribute? It's called n-region key. What does this do? This will still return 25 because I have 25 records. Does that make sense? But let's say your objective is to count how many distinct regions these countries are from. Obviously, this doesn't do the job for you, right? It returns still the number of countries you have. So what you do is you do this. Select count distinct from nation, right? So this gives me 5. That means these countries are from 5 different regions. Okay, so that's the difference between count and count distinct. You can actually look at the query plan of this. So when you do expand, it will show the query plan. Right? You scan, then you do the aggregate. So you scan the database, then you aggregate the results. Okay? So that's a query plan for this one. Does that make sense? Okay. So let's come back here. Now you understand the basic aggregates. And the same goes for average and sum. One thing that's interesting to point out is the distinct keyword has no effect to max and min aggregations, right? Because whether you remove duplicates or not, the max and min value of your data set stay the same, right? So it's duplicate. This is what we call duplicate insensitive. Duplicate insensitive. However, there are something that's interesting, which is the following. Suppose I want to find the sailors, the name of the oldest sailors. The name of the oldest sailors. How do I do that? The name of the oldest sailors. Well, it's tempting to do this query on top, right? Select the name, max age, from sailors. So intuitively, it looks like this might return the name of the older sailor and his or her age. Okay? But in reality, what happens? Let's check this against the database we have. So which one might have an ordering? So let's see. So line item has quantity. Okay, suppose I want to do the following. I want to find the order key. So line item is a particular item, shows which order has been placed on which particular part, and what are the number of quantities on that particular part. Does that make sense? So this is what this database is representing. This particular table is representing. Suppose I want to find the order key with the maximum quantity. Do you follow me? The order key with maximum quantity. Using what we have set here, what are you supposed to do? You do select order key and max from line item, right? Is that right? Do you follow me? Can you see? Okay? You see that now? So it's better, huh? So that's what you do. And what do you get though if you do this? You get a order key. So in Postgres SQL, this actually complains an error for you. You actually cannot do this in Postgres SQL, in this particular data server. So that's why I'm hoping we get that MySQL database up. But I'm not able to connect to it. So a complaint that this aggregation, this one, must be from a group by clause. This might sound very confusing to you for now. Later on, I will explain what is a group by, and you will understand what's going on here. But let's just think about from what we have learned so far. So I cannot connect to MySQL. Anyway, so I will do that experiment next time when the MySQL database server is up. So if you do this in MySQL, what happens? If you do the same query in MySQL, it doesn't complain an error to you. Again, as I said, this really depends on the particular window you're using. What will happen is, if you think about the basic semantic of select from where clause, what do they do? You do the cross product. In this case, what is the cross product? The cross product is the sailors itself. So you get the sailors table back. Then what's the next step? You iterate through the record in the cross product one by one, and you do the projection. Does that make sense? That's the basic semantic of SQL block. So what happens? You get the sailors table back, you iterate through the sailors one by one, sailor record one by one. For each sailor record, you project out what? The name and the max age of that sailor record, which is the age of that sailor record. So what you get is simply the list of sailor names and list of age values for each sailor. Using that select from where semantic we have talked about. Which is wrong, which is not what you intended to do. Does that make sense? Because your aggregation in this particular case is applied to each sailor record one by one rather than as a whole. In PostgreSQL, we realize that many developers may make mistakes like this, so they even reject you from trying to write a query like this. So that will give you error. But in MySQL, they're more friendly, I would say. So they allow you to run this query, but you end up with a wrong result. So what's the right way of doing this? How do you find the name and age of the oldest sailor? You have to use a nested query. You have to use a nested query to do this. So in the block, what do you get? What does this do? This one simply find you the age, the maximum age value from all sailors, right? Translating to our database, if I do this, is there a way to just turn off this light without that? Turn this off? Okay, better, right? So if you run this, what do you get? You get the max quantity from line item. Now this will take a while because this database actually is not so small. So let me let it run, and I will come back and show you the results in a minute. So this will return you the max age value from the sailor table, right? Do you follow me? And it's a single value. Now the outer block, what does it do? What does the outer block do? Yes?
Goes through the sailor table and returns any name where the age is equal to your inventory.
Excellent. So what the outer block does, as she said, is to go through the sailor table and for each sailor check the age value against the max age value, and if it matches, you must be a sailor with the max age value. In other words, you are one of the oldest sailor. Why I say one? Because there could be multiple sailors tied on the age value at the maximum age value, right? So you return all of them. So that's the logic here. So this query is still running. So even for a simple query like this, it can be expensive when your data becomes large, actually. Now, Another way of doing the same thing is to say, okay, instead of using an aggregation value here, I use all the h value here. I simply find all the h values in my inner block. Then I do another outer block, just like before, but I change this condition to, instead of to equal, I say greater than or equal to all of this. What happens? What does this do? It accomplishes the same thing, right? Because you A, in order for sailor to be returned, his or her h value must be greater than or equal to all the other sailors. In other words, you must be one of the older sailors. Let me change this query a little bit and ask you what the following query does. What does this query do?
Returns all except the smallest.
Go ahead.
Return all.
Louder so people can hear you.
No, return every sailor except the smallest, or the youngest.
Return all the sailors except the youngest. Right, because except the youngest one, there must be at least one other sailor, which is the youngest one, whose h value is smaller than you, so that you will be returned. Does that make sense? Okay. All right, fantastic. So we're doing. So finally, this returns. So the maximum quantity is 50, so I will type that query and let it run. So what you will do is order key on line item where equal to this. And this will give you the order key that has the maximum quantity, meaning which is your most profitable order. A manufacturer company want to do this all the time. You want to find out which customer ordered the most number of parts from my production, right? And I want to show the quantity as well, which not surprisingly must be the max quantity. So this query again will take a while. I will let it run and come back and show you the results. Any question on this? Fantastic. Okay, now, see, this database actually complains about column line item order key must appear in the group by clause or be used in an aggregation. What does this mean? That's exactly what I'm going to talk about next. Group by, then I will talk about what the error message actually means. Okay? What the error message actually means. And not only I will explain what the error message means, I will explain to you why the system has to report an error like that. So group by is a very useful construct. Suppose I want to find the number of students we have at the U. That's very simple. Select count star from students where university equal to or institute equal to University of Utah. That gives you the total number of students at the U, right? Suppose the student table has students from different institutions. So I just use the selection condition to do that. Let me ask you, you get the results, then you both said, okay, fine, fantastic. What about, I want to know the number of students at U by different departments. Show me the number of sales students you have, number of business students you have, number of psychology students you have, so on and so forth. How do you do that? Well, one way of doing that is the following. You say, okay, I got it. I will go and do this. Select count star from student where institute equal to University of Utah and major equal to CS. One down. Select count star from student where institute equal to University of Utah and major equal to business. Two down. So how many major we have? I don't know. How many major we have at the U? Huh?
A lot.
Definitely not 2 or 3, right? If it's 2 or 3, I don't mind doing what I just said. But if it's like 20, 30, or hundreds, I don't know I want to do that. I don't know I want to do that. So translate to the example here in the slide, that's exactly the same thing, right? So I want to find the youngest sailor from each rating group. Different sailor have different rating values. I want to find the youngest sailor at each rating group. This makes sense, right? If you're doing a Olympic competition, you are interested in finding out the youngest sailor, but you want to do this for each different rating groups. One way of doing this, if I tell you there are 10 distinct rating values, you can simply do this. And iterate through I equals 1 to 10. Do you follow me? Fantastic. Now, you do this, right? Then one day, the association changed their rules. They said, good news, we're going to have, based on strong demand, we're going to change the rating scale from 1 to 10 to 1 to solid. Okay, now you were the one who wrote this code before, now you are in trouble, right? Because you have to type this for solid times. This is really bad. So how do you do this? So that's what we will do using group by. So what you do is, so this is the construct of the group by code. The select from where is as before, okay? With some subtle exception, on the select clause, which I will come back and talk about that in a minute. That actually explains why we get the error message we saw earlier. Okay? Now, you say I do group by. I supply what we call a grouping list. A grouping list is nothing else but a list of attributes that you will do your partition based on. So in the earlier example, I want to find the number of students per major, different major. What I do is select count star from students where institution equal to University of Utah, group by major. Suppose there's a major column. What that means is you're doing your partition of your data based on the values from those attributes in the grouping list. In that particular example, your grouping list has a single attribute. So the partition is done by the major value. So all CS students end up in one group, all business students end up in one group, and so on and so forth. And then the logic is you apply your aggregation over each group individually. So you have the count done over CS group, the count done over the business group, and so on and so forth. Any question on this? Now I gave you an example where grouping list might be more than one attribute. Suppose you boss said, oh, fantastic, you can do that. Okay, I know the number of students in each major. Now I want to drill down a little bit deeper. I want to understand if there is any correlation between the age of the student and the major they're in. There's a hypothesis, oh, younger students tend to favor computer science. They love studying computer science. But as you grow older, you probably don't want to do computer science anymore. You want to do something else. I mean, this is not a most political thing I ever said, but anyway. Okay? All right. For the purpose of illustrating the example, right, let's use this not so 100% political correct statement, right, that I want to do. So what do? What you want to do? Well, what you want to do is return a count by major, but at the same time by age value as well. In addition to major, you want to group by age. Does that make sense? Do you follow me? So what you do is select count from students where institute equal to University of Utah, then group by, excuse me, group by major and age. So your grouping becomes, so when you do this, you okay? So what happens now with this group is you're doing group by major and age. What end up is, suppose this is your data. in all the student records. What happens is you will take these guys into one group. What are these guys? Suppose they are CS, they must be all from CS, and their age value is 18. So these folks will end up in one group. And then these other folks, let's say they're also CS, but they're 17 years old. And then they will end up in one group. And then you have business majors, so on and so forth. Let's see. Business and 19, so on and so forth. And they will end up in one group. And then you apply the aggregation over each group. So each group now becomes a set, right? So you return the count from here, and count from here. That make sense? So what you get is, at the end of the day, yeah, go ahead, question.
Is the ordering of the statements important? Like, what if you were to group them by age first?
You mean versus this, right?
Yeah.
No, because really, if you think about it, suppose one record is CS17, the other is 17 CS. As long as the corresponding value are the same, they end up being the same. So order doesn't matter. Question over there?
To return the total count for each aggregation added together, or?
Per group. It return an aggregate per group. Yeah, per group. Then, answer your question? Okay. Now, so suppose I have like 10 different groups. So what will be the output? That will be 10 different counts, right? So let me illustrate this using a real example here. So by the way, this course finished. So actually there are many orders with maximum quantity. This is a fake database, obviously. Right? Oh, I don't want to do this. So I want to do, let's go back to the nation table. Has nation key and region key. I want to do a very simple thing. And we know the earlier query I run has 5 distinct regions. I want to do a very simple thing. I want to find what I want to find. I want to find the number of countries from each region in my database. Does that make sense? Number of countries from each region. I know how to do total number of countries. That's easy. Let's just this 25 countries. 25 countries, 5 regions. I want to know how many countries are from each region. How do you do that? Well, you can group by, right? So select, count, from, is it nation? Yeah, nation. Group by, what's the attribute name, do you remember? N region key, I think, what it is. Right? Do you follow me? Well, I was saying this cannot be a uniform distribution, and it turned out to be. So 5 countries from each region. 5 countries from each region. Okay. Again, this is a fake database. Obviously, that's not the case, right? The European continent has way more countries than the North American continent, right? So that's what happens here. Now, you may want to do something further than this. You say, okay, this is fantastic, but how do I know which continent has how many countries? Which region has how many countries? This shows the count of each region, but doesn't show me the association of the two. Does that make sense? So I can easily fix that by saying, okay, I want to do, I can do this. Right? So what do you got? You got these ones. And the output is not nice, so I want to even order by region key. So I got a nicely formatted output. Does that make sense? Okay. So now let me try something different, which is I want to do this, but let's remove the order by to not confusing you. As I want to return, in addition to region key, I also want to return nation key. show me the count of number of countries from each region and the nation keys, right? Does that make sense? Now you got this arrow back, where it says nation key must appear in the group by clause to be used in an aggregation function. Why is this? Why is this? The reason is the following. If you look at the output, how many groups we have, by the way, by this group by nation region key? We have 5 groups because we have 5 regions. We have 5 regions because we have 5 distinct values on the region key column. Doesn't matter how many times they all collectively appear in this database. There are only 5 distinct values, 0 to 5, 0 to 4 for region keys. So you will end up with 5 groups. You follow me? And the semantics of your group by query is the following: is that for each group, I will return 1 record to represent that group. I will return 1 record to represent that group. So whatever record you are going to return must show you a consistent representation of all the records in that group. So it makes sense to return, for example, region key. Why is that? Because all records in the same group must have the same region key value based on our grouping requirement. It makes sense to return an aggregation like count. Why? Because no matter how many records you have in one group and how different they are, after you do aggregation, they become a single value to represent the whole group. You follow me? It does not make sense to return nation key, however. Why? Records in the same group must have different nation keys values. When you ask me to return just one value, which one I should use? I don't know. It doesn't make any sense. Does it make sense? So that highlights the important requirement of group by query, which is, coming back to my slide, which is the target list, which is the select clause, must be one of the following. Must be either an aggregation operation, or attributes from the grouping list. So it can only be those 2 types of attributes in your target list, rather than any arbitrary attribute, like in the typical select from where clause. The reason is what I have just explained just now. You can use an aggregation attribute because it aggregates all the records into one. You can use an attribute from the grouping list because all records in the same group must have the same values for the grouping attribute. So it makes sense to return that value to represent the group. But if you try to use any other attribute, it doesn't make sense. How this record in the same group must have different values. How can you use a value to represent nation key for records in the same group when they have different nation key values? Does it make sense? Okay. All right. So that's the fundamental requirement of group by. And now, if we go back to the query I ran earlier, that I got an error message from the system, which is this query here. So if I run this, what happens? What happens is PostgreSQL, whenever you do an aggregation, view this as a virtualized group by query. So it groups the whole thing into a single group. The entire relation, when you have no grouping attribute supplied, and you are using an aggregation operator, it actually views the whole table as a single group. So virtually you are doing a group by. Does that make sense? And so it accepts that in that case it's okay to return this, but it's not okay to return this because records in that single group have different order key values. So it makes no sense to return this. If you think about this, what's going on here? This is actually the same as if I may, of course this is not a valid SQL expression, but the logic is essentially when you do select max from a table, it's like select max from this table when you push all records into a single group. Virtually, that's what you do. Does that make sense? Yeah? So this makes sense because you can return an aggregation to represent that group, or you can return an attribute from your grouping list. In this case, there is no grouping list to begin with, so any other record you try to return, the system will report an error back to you. The final remark I will make today before I let you go is that this behavior we have just observed, this behavior we have just observed is vendor specific, is system specific. So PostgreSQL report this error, but if you try the same query on MySQL, it actually does not report this error. Actually, I believe the latest version of MySQL, when you try to type this, I think either MySQL or some other database server, I forgot, what it will do, either it will return what I said earlier, right? All the order key and the quantity of each order, which is always wrong. In my opinion, it should just give you an error message. But if they return that, that's okay, because the developer will realize that's wrong. Some database server is trying to be really smart. When you write this, they guess, oh, what you mean is find the quantity, find the order key with the maximum quantity. Inside the engine, when you write this, they translate this into, they will translate this into this automatically for you. In my opinion, if you ask me, that's a really bad thing they have done, because the developer will never realize they're doing something wrong. This is one case where if you're trying to be too smart, you are actually doing a damage. And that happens all the time. Right? So I will stop right here. We'll continue on next one.